Unite beyond boundaries. Innovate together. Joe's PANKRATION 2024. No border.
押してください。
Hello, everyone. Thank you for attending the presentation. My name is Marco Gonzalez, and today my topic is Private Edge 5G. Are multi-cloud or multi-vendor solutions the key? Is eBPF the ultimate tool to add? Let me give you a quick self-introduction. I was born and raised in Lima, Peru, but I'm living in Japan since 4 years ago. I work at Ericsson Japan, working as a 5G solution architect. In my free time and being an AWS community builder, I love to work in IT blogs regarding 5G and latest technologies with 5G and OpenAI. Besides that, I have some hobbies that I enjoy in my free time. So the agenda for today is private 5G. What are the future challenges? eBPF to the rescue. AWS private LTE and 5G catalog. A quick demo architecture, a demo GitHub, and few takeaways. As a quick disclaimer, this presentation contains personal opinions and my insights. It does not reflect my company or employer perspective. Okay, so let me start with a quick question. What is private 5G? And for that, I rely on OpenAI ChatGPT. I asked a quick simple question. Give me one line. What is private 5G? So I can use in the upcoming job PANKRATION presentation. In one line, private 5G is a secure, high-performance wireless network designed exclusive for enterprise, offering coverage, security, control, and data privacy. As you may imagine, 5G technologies is up to now the latest technology for wireless communications, and private 5G is focused on business. And why this is important? Because of the current problem statement, private 5G has a big concern. How can it be how can it make profitable? How can it be monetized with multi-cloud or multi-vendors? What are the best options for it? In few numbers, by 2028, it is expected that private 5G will have a $7 billion US revenue. And by 2028, around 18,000 private 5G and LTE will be in place. How that's possible? Because the change of mindset from the companies. They are moving to a business model innovation using 5G, Gen AI, and other drivers. What is more, companies want to improve security, control, and management. And for that, private 5G is the way to go. Last, this is a new ecosystem. 5G, as we imagine, it's not only customers, it's not only users, but also companies. There is a way to say that private 5G must be a one-stop shop. Multi-vendor choices, but one-stop. So how does eBPF place into picture? To not make it too complicated, eBPF is a technology designed to take away all the overheads, all the complexity that some of us may know when we work in the multi-clusters or the cluster solutions. And this image, which can be a bit daunting for some of us, shows how the networking is in place for EKS cluster or any Kubernetes cluster. To put in short, what eBPF does is remove all the overheading, all the heading that the common or the usual routing will be in place. In short, it will remove all these layers, all these steps that only add overhead and will have only one stop. How will this improve the 5G solutions? Because it adds what 5G needs the most: speed, performance, and management. A quick comparison. between the eBPF and some other networks, traditional methods. Basically, as I mentioned before, is performance improvement, resource utilization, security, scalability, observability, and troubleshooting. It has been proved since over 5 years ago that eBPF is the way to go for multi-class solutions and recently AWS EKS solutions. I just mentioned these key KPIs, but in the long, short, medium-term future, private 5G must need these kind of technologies in order to be a potential solution for the customers for many use cases ahead. Okay, so where is AWS in all this universe of 5G? So let's start with the simple ones. The first solution AWS offered was the AWS Wavelength. It's just, in simple words, an edge solution, a private 5G edge solution to the edge next to the customer. The next one is the AWS Local Zones. Basically, same approach, lower latency. Third one, AWS Outpost. Similar approach, specific use cases, and latency management and security were keys. As we all know, the all good EKS, ECS, and Fargate are also part of this catalog. A Network Builder is an AWS offering to automate the end-to-end deployment for LTE and in the future 5G technologies. Route 53 and S3 has been these primitive technologies that we all use until now, so definitely will be part of the catalog. And in the middle is the latest, by far the most complete solution by AWS, private 5G. It will handle the end-to-end deployment for the private 5G and is focused on business and B2B solutions. So in this demo, I tried to focus the solution on technologies like EKS, AWS CDK, and basically eBPF based on Cilium, which is the well-known provider of this technology. As you can see in this architecture, I implemented by using AWS CDK, which allowed me to deploy EKS using just software development tools. I use TypeScript, but I can be used Python or any other languages. The benefit of this is I can implement the cluster in less than 30 minutes. And if I find any issue or any trouble, I can just simply destroy and then recreate again. Besides that, I can add multiple add-ons components that are features that AWS offers to the many customers. As you can see in this diagram, I have two subnets divided with the Open5GS, which is what I implemented in this demo to simulate 5G solutions, and the SRS run that will simulate the RAN access. What I'm trying to demonstrate in this demo is basically that it can be achievable. It can be possible to implement private solution using open source technologies, and with the performance improvement of Cilium, it will add security, observability, and if I add it to the existing tools from AWS CloudWatch, it's a way to go to offer private solutions. And why not have customers, B2B customers using this? So for the demo, I cannot go all the details that I want, but I have add all the information in my GitHub. It implies all the different details. And if I can give a quick look of it, I will just quickly mention this. So in my GitHub, you will find all the steps that I follow to implement this private 5G on EKS. What is more, I added the code, so it can be straightforward for any of us who wants to implement this. And after following these steps using CDK, you can then deploy your open source. In my case, I decided to use Open5GS, which is just Helm commands to implement. Of course, this implementation does take some troubleshooting in place. Open5ds or open source solutions uses NoSQL databases, which demands some knowledge about those storage technologies, about load balancers, but overall is a very fruitful demo for those who want to try it. As I mentioned in my GitHub, you will find the Helm commands just to pull and install these packages. And after that, we're good to go. How you can verify it? Simple commands, verify logs, and you can verify the connectivity between this deployment. Going back to my presentation, and due to the lack of time, I will just move to the takeaways. So in today's presentation, I try to present what are the assays for the private 5G networks. Private 5G has a long and a potential fruitful future. It demands investment from companies, but overall, it demands technology. End users or private 5G should seek a single comprehensive solution that offers multiple vendors to create an ecosystem, what I call a multi-vendor ecosystem 5G. Second, innovation in business models will play a key role in the private 5G race. AWS, as I showed today, has a catalog of many solutions. Some of them are new, some of them you have already used it, and it is AWS customization provides programmability, automation, and besides that, uses the advantages of cloud and edge technologies. Last, eBPF, as I quickly explained, is this additional tool to expand 5G capabilities and build what is defined as a service mesh layer on AWS EKS. It is just a couple of commands. It doesn't require too many background of eBPF, so please don't feel scared if that name sounds very daunting. And what it does, it provides networking, security, observability features that can be used as a Linux kernel, because that's what eBPF is for, to implement all solutions within Linux kernel. With that, concludes my presentation. Thank you so much, and I will be here for any questions or discussions. Thank you.